Hello, my name is Stavros, and today I'm going to present to you my project for WAICY 2022. Sign language classes in my school highlighted the need for sign language recognition as an accessibility feature. After realizing there was no easy-to-use free software in that field, I decided to develop SignTrack. SignTrack transcribes sign language to text from a real-time video feed. The model makes predictions on what you sign instantly. After completing your sentence, an additional processing layer restructures your sentence to follow grammatical rules, which are different in sign language. Creating a custom model requires minimal coding skills, a graphical interface, and assists you throughout the data collection. And with the power of auto-train, training your model does not require complex adjustments. SignTrack builds communicational bridges, forming a more equal working and living environment for everyone. With applications like live translation in teleconferencing meetings, assisting people who start learning sign language, or as an alternative input method, it is clear that the project can have a meaningful impact in our society. SignTrack utilizes a state-of-the-art LSTM model that predicts based on a sequence of data, enabling the prediction of whole phrases and moving signs. To further improve precision and efficiency, SignTrack has been trained only on key pose and landmarks that have been extracted using MediaPipe. That way, it also remains accurate on every skin shade. The project is split into three main parts: data collection, model training, and model utilization. Making the data collection experience friendlier for the user has been one of our top priorities. That's why we made sure to create an easy-to-use data collection user interface, even for those with minimal coding skills. Data plays a fundamental role in creating a great model that's both accurate and has great performance. With breaks between training sessions and intuitive design, anyone can create a good training dataset. Another feature of data collect is flipping the image to generate data as if you signed with the other hand too, creating a model that can make equally accurate predictions on both hands. It's also worth mentioning that privacy is at the center of SignTrack. The collected data is free of personal data, like raw images. It only stores numerical values of key point positions as NumPy arrays, making our users feel more comfortable exchanging datasets. Let's see that in action. Now we are going to collect data for C. As you can see, the program shows me when I have to sign, and it automatically saves only the key points of the needed landmarks. Let's move on to model training. Training a neural network can become confusing. Everything in SignTrack is automated with the power of AutoTrain. AutoTrain automatically sets training parameters such as the number of feedbacks and data split. What's more, FastTrack has been implemented right through the model training process, a new way of data augmentation that improves the performance of the model. Last but definitely not least is model utilization. As you can see, the consistent, unique and identifiable design follows through the last part of the project, while keeping on display all the needed information about the accuracy of specific signs. That can save a lot of time for those who make their custom model, while FastTrack is built right through the main part of the project, so that it makes predictions faster than the 24 frames that the model needs. And it also adds the punctuation at the end of its sentence. You can always find out more in our website on edukit.org/piperakis/SignTrack, or you can ask me via email. Thank you for today, and this is the end of the presentation. you.